How'd it go? Oh, I missed you guys too. Thank you. That's so nice. Okay, this one, in the interest of time, I think we're going to skip this one. If you gave it a try, that I encourage that. I will maybe throw you an extra credit point if you had a decent thought. But we're going to hit that hard tomorrow. It's a big idea. Instead, let's go to the back real quick just to see how you did on that. I'm thinking we'll do a accumulation of change word problem, AP, free response this week as a quiz, maybe do a Parker quiz or something like that. Yeah. If you stink at these, you don't want to be embarrassed in front of your partner and be a total idiot. So I suggest you get help so you're not just baggage that your partner has to lug around and you're actually a help to the team, right? Okay. So let's go here. Did you get a graph that looks something like this? Excellent. All right. So 8, you should always use the window if they give it to you. All right. Now, R at 3 is, did you get something like 12-ish?
Yeah, 12.68.
Negative 12-ish?
Yeah.
Okay, negative 12.682. Okay, let's go back and then record that and interpret it. R at 3 is roughly negative 12.682. R should not be hard to interpret. It's given what it means. It says R is the rate at which population in an island is changing in people per year. So the thing that I have seen that people are leaving out is a reference to the 3. You have to make reference to the time, not just the answer. So you should be showing both of these in your answer. So at time equal 3 is good. At time equal 3 is good, but better is in 2003 is what time 3 refers to. The population is changing is okay, but on the AP test it wouldn't do. Rates of change need to be interpreted for sign. So the population is decreasing. You should show the keywords at a rate of 12.682 people per year. Okay, there's no reason to round. Rates can be decimals. Leave it a decimal. With me? All right. The interpretation of this, some people can interpret this the way it is. Some people can use the units as a guide. Remember, these are sums of rectangles. What's the height of the rectangle? What is R? And what are the units on R, rather? Sorry. People per year. It's a rate of change in people per year. And what are the units on DT? A little amount of time. Years. And so what are you finding but people? All right, now, so I know I'm finding people in some fashion, but what does that mean? Is it finding the people on the island in 2003? No. Is it finding how many people are on the island from 2000 to 2003? No. Okay. This is where it helps. It might help anyway. I don't require this, nor would they grade for it on the AP test, but it might conceptually help you to think, all right, R is like a derivative because it's a rate of change. It's like a derivative. It's the derivative of population. It's how population changes with time. And if we then think in a fundamental theorem-y way, what are the two things you do when you do a definite integral? What's the first thing you do? If I said, hey, do this definite integral, what's the first thing you do? Integrate or anti-differentiate. What's the antiderivative of P prime? P, okay? And then isn't it at the upper minus the lower? So all these things mean the same thing, but this is pretty clear. It's the population in 2003, take away the population in 2000, or the difference in the populations, or the change in the population. Integrating a rate of change gives you an amount of change. It doesn't give you amount, it gives you amount of change. So you would say something like this answer is, first you get the answer, I didn't find it. Was it negative 60 something or other? 67.082, okay? You can round that to the nearest person, or round it to the nearest person in a second. So what does this mean? Does it mean 67 people left the island? It doesn't mean that, because some people could come in, some people could leave, some people could be born, die. What does it mean? First, you need to make reference to the time from 2000 to 2003, the number of people or the population on the island decreased by 67.02, or by approximately 67 people. By what? If you round it, you publish. I don't know if they would count off that. Okay. They would be very clear on the AP. I write these myself. So on the AP test, they would be very clear. Hey, round your answer, or hey, don't round your answer. They'll say, round your answer to the nearest. Okay. I just take shortcuts. All right. Find the population in 2003 using the fundamental theorem of calculus. Okay. So, does that mean I'm supposed to get the population function, I'm supposed to integrate that and actually find the antiderivative?
No.
Yeah, you're going to use your calculator, because you can't do the antiderivative. That's not something you can anti-differentiate. You're going to use your calculator. The question is, so we know that this kind of deal gives us amount of change over a time frame, right? Not population, but population change. Where should we go from and to? What time frame?
0 to 3.
0 to 3 would make a lot of sense. Unfortunately, okay, so let's go there. Let's go 0 to 3. Isn't that p at 3 minus p at 0, right? Now, I could do this in my calculator. Boom. This is what I want. To do that, I would need to know is 0. I don't. Do they give me p at some other time?
You actually.
What time? Okay, so I think you used the wrong time frame. It makes sense to go from 0 to 3, because starting at 0 is just a logical thing to do, but you really should go from where you want to where you know, and that's, or vice versa. And we know 2005, and we want 2003, so what we should be talking about is 3 and 5 here. Where should I put the 3 and where should I put the 5?
3 on the bottom.
You should always put the lesser on the bottom. So go from 3 to 5. When I integrate that, that's p at 5 minus p at 3. All right. So that's when I say the fundamental theorem, it was very fundamental. It's just, when you do a definite integral, what do you find? It's the antiderivative at the upper minus the lower. Cool? Now let's isolate what we want. We want population at time 3, eh? So let's move this over there so it's positive. We're going to add that over there, and we're going to move the integral back this way. So the population at time 3 is population of 5 plus or minus the integral? Minus the integral, 3 to 5. And what is this really doing? We're saying the population in 2003 is like the population in 2005. Take back the change that happened. Undo the change. Remove the change. So here's where our calculator comes in. We know p at 5 is 1200. The calculator does the integral. So 1,200 minus, how do we get a definite integral in our calculator? Shift plus 3 to 5. I have the function in there for us, x, t, x. And I get 1,183.689 or 690, whatever you like. We're gonna also round it. What did I just say? 1,183.689. Alright. This is roughly 1,183.689 or 1,183.84 people. Is it people or years? Or days? It's people. Okay, population. So you with me?
Yep, I'm with you.
All right, cool. The lessons I'm kind of juggling a little bit, so I wasn't here to teach 54 yesterday, so I'm going to teach 54 today. Would you get out those notes on velocity, acceleration, and such? This is actually derivatives and integration applications, so I didn't know what color to make it, but it is what it is. Okay. The front hopefully will go pretty quick and pretty well. We already know that velocity is changing position over time, and therefore velocity is the derivative of position. We know that acceleration is the change in velocity over time, so acceleration is the derivative of velocity, or the second derivative of position. That's old, yes?
Yeah.
Would you, that's what I was looking for. Would you try that first example on your own, and I'll call on some people randomly and have them share your answer.
Hey.
I didn't sort them at all yet. Okay. Not ready or another minute? One more minute. All right.
Oh, calculator, okay? No, calculator, show. Only at the page. We don't need to show work on it. We can circle random answers and we'll be done. Same. Okay, I got it.
So, 30 more seconds. Shoot. How give me a number between 1 and 23.
13.
13. That's yourself, ironically. Okay, so.
Oh, jeez.
What is the derivative? Do you agree that to find the velocity we need the derivative?
Yeah.
Can you read your derivative? The derivative, not the numerical. Just
Yeah.
what is the derivative?
I said 4t
Okay.
times natural log of t plus 1
All right.
plus 2t squared
Right.
times t over t plus 1.
Times t over
Oh,
t.
wait.
Oh.
Oh, wait.
He caught it. He caught it. 1 over t plus 1.
Yeah.
Okay. Cool. Give me another number between 1 and
14.
14. 14. Alex. So what'd you get for v at 2? 8 log 3 plus 8 thirds. I agree. Do we all agree with the first part?
Yup.
Cool. Alex, give me another number between 1 and 23. 12. Okay. Oh, did you say, 12, sorry, that's Andrew.
Yeah.
How do I, first of all, communicate? I know you're doing the calculator, but you need to communicate, hey, this is what I did. So don't just give me A at 2 is this. Give me some calculus. A at 2 is what calculus? They would take either one of two things, either x double at 2 or what else? V prime at 2. Either way, you need to communicate. What was your numerical derivative, sir?
I got 8.839.
Okay, do we all agree there?
Yep.
They did not give units, so I guess we're good to go. Any questions on the first one? Nice, easy warm-up, but it'll get harder. Okay. Given the position function, we'll find where the car is moving right and accelerating by making a table of velocity and acceleration signs, all right? So we want to start by gathering the evidence. How do I get velocity? Lexi, how do I get velocity?
The derivative.
Wonderful. And what is the derivative of position, Aaron?
Velocity.
Aaron?
Oh, sorry.
3t squared.
Wonderful. How do I go about finding the 0 there, Radhika? Factor. Let's take out a 3. And, oops, plus 3. And so what are the zeros, or how do I factor that? Heather, how do I factor that? What? Oh, sorry.
30x minus 1 is x minus.
I agree, but with t's. And so our zeros are 1 and 3, eh?
Yup.
Okay. We'll use those on our chart in a second. Hold on to those. Now let's go to acceleration. They said make a double chart. So how do I get acceleration, Campbell?
You say what's the derivative of
Well done. And what is the derivative of velocity, Brian?
6t minus 4.
Yes, indeed. And what's the 0 there, Evan?
That would be 2.
Yes, indeed. All right. So now we're going to make a big old sign chart with 3 rows: time, velocity, and acceleration. The time intervals start, notice they said start at 0, yeah?
Yup.
So our time intervals are going to go from 0 to 1, 1 to 2, 2 to 3, and 3 to infinity. The velocity and the acceleration, we're going to chart their signs in each time frame. All right, so this will be 8 good questions. Holland, from 0 to 1, what's the sign of velocity?
It's positive.
I agree. Let's just keep going with velocity. Matt, from 1 to 2, what's the sign of velocity?
That would be negative.
I agree. Miranda, from 2 to 3, what's the sign of velocity? I agree, it's negative. Alexandra, from 3 to infinity, what's the sign of velocity? I agree. Mr. Burgess, let's switch gears and go to acceleration now. From 0 to 1, acceleration sign is? Negative. Oh, don't give me that ooh stuff. Mr. Garcia, From time 1 to 2, what's acceleration? The sign. Negative, I agree. Let's see, Emily, from 2 to 3, what's the sign of acceleration? Positive. And Bailey, sign of acceleration from 3 to infinity? Positive. All right, now let's answer the question. It should be a layup now. When is the car moving right and accelerating? I'm looking from the table where, what's happening, Harrison? Both positive, and so we conclude the answer is 3 to infinity. They didn't say it, justify it, so I'm just going to say that. All right? Are we done?
Yep.
Okay. Let's go to the next example. These are all just typical calculus problems that have to do with motion. Just want to make sure there are no holes. I hope they're easy. Given the height of the ball, height of a ball, thrown up at an initial velocity of 5 meters per second from an initial height of 2 meters, is that equation. Later on, we'll actually develop that equation. Then I'll just hand it to you. Find the maximum height of the ball. What's the greatest height the ball reaches? Now, this is meant to be a no calculator kind of question. Unfortunately, it's metric, so it's kind of included. So fight the temptation to just graph height and find the max of the. It's calculus class, not calculator class. So what should we do? Max height, calculus-wise, what's the big idea? Max height is when?
It goes plus H.
What do you mean it?
H prime.
H prime. The maximum is where its derivative, the height's derivative goes
Positive to negative.
positive to negative. All right, so certainly we'll need H prime. H prime is negative 9.8 T plus 5. And let's find where it's 0. This is 0 at, feel free to leave it ugly, Kindle, this is 0 at 5 over 9.8. When I test H prime around 5 over 9.8, if I try maybe at 0 or something, that's about a half, you know what I mean?
Yeah.
So at about 0, this derivative is positive, and afterwards
It's gonna be negative.
negative. What is that? What does H prime again mean?
It's the rate of change.
It's the rate of change. It's the
Slope.
slope. Still not there.
Slope of
The
the change.
derivative of height is
The change in velocity.
velocity. So open for velocity. Good try. Good stuff. So I found where the derivative went positive to negative. So why is that the max height? Because if the velocity is positive, it was moving up. And if the velocity is negative, it's moving down. So if I found where the velocity goes positive to negative, surely I found the top. Yeah? So is my time then, or is my answer 5 over 9.8?
God, no.
No. What is the question asked?
Oh my God. Find the maximum height. I would do this.
So how would you do that in your calculator?
I would graph that.
You'd graph it and do the value, or you'd graph and do the max, or you'd calculate that and store it and then just throw it into that equation? I'd calculate and store, but do something. Somebody calculate an answer for that, please.
Hold on.
It seems like it started at 2 and went up, so it should definitely be above 2 as a max height. 3.275? What are the units on it? What are the units?
Meters per second. No, meters.
Meters. Okay, so about as high as the ceiling. He just threw it up a little, or she just threw it up a little, and peaked and came back. All right. Last but not least, for the derivative side, given the position of a runner in the table, estimate her velocity at time equal 3. So I'm giving you at different increments where she was along a track or something like that. We're trying to estimate how fast was she going at the instant time equals 3. So let's talk calculus. V at 3 is calculus-wise the derivative of position, yeah?
Yes.
All right, now I can't actually calculate the derivative because I don't have an equation. And so I can't do the idea of getting microscopically small think of trying to find her position one place and then 1 microsecond later. That would be a good approximation. I don't have that small a time interval, so I'm going to approximate instantaneous rate of change. Write this in your notes. Approximate instantaneous rate of change with average rate of change over an interval. The best I can do is say, well, around 3, he was going or she was going blank. Now I actually have 3 choices here. I could use how fast, where she was at time 3 and at time 4, and say the difference in position over that time frame was, she went 8 meters in 1 second. So maybe she's going about 8 meters per second. Or you could say how fast she's going. Instead of 3 and 4, I could use 2 and 3. And that would be more like x at 3 minus x at 2, change in position over change in time.
7/1.
That's 7/1, 7 meters per second. You actually could go one more. Think symmetric derivative. So instead of saying at 3, I'm going to use a point on the same side, either side. And so I could do, the derivative at 3 is 4 minus 2 over 4 minus 2 over a 2-second time frame. And that's more like, 15 over 2? Or 7.5 meters per second. All 3 of those are good, but could you use 0 and 2?
Oh, no.
No, that's not as close as, I mean, in the definition of the derivative, don't we have that limit there? Say, get as close as you can to the point. So 0 and 2 would be a violation of that idea. You could not use 0 and 2. All right, you with me? All right, let's go to the other side. Went Scottish there for a minute. Okay, let's go to integration. Now, a car is accelerating. Now they're giving you, way down the line calculus-wise, they're giving you acceleration, so that's like the second derivative, and they're asking you to go backwards, again, calculus-wise, to get to velocity. Start with the big idea of calculus. Show the big idea. Velocity is the
It's the derivative or the antiderivative of acceleration.
So if acceleration is the derivative of velocity, then velocity is the antiderivative of acceleration. Believe?
Yep.
All right. So if I integrate 7e to the t with respect to time, what's the antiderivative of 7e to the t? 7e to the t plus a c. Now you're going to use a given initial condition to find the c. What v and t do they give you? All right, now make sure you put stuff in the right place. When you say 3, is that the velocity or the time? See, the velocity is 3 when the time is 0. So should I just say it's 3 because 7e to the 0 is nothing?
No.
7e to the 0 is 7. If I
Plus c.
remove the, if I say 3 is 7 plus c, then c must be
-4.
-4. Now I complete the equation. V is
7e minus 4.
7e to the t minus 4. Now that I know the c, I can complete my equation. And I'm done. You with me? Okay. Say a person bikes with a velocity of that function at any time.
Oh.
If the position is 3 meters at time 0, find the equation for position. So they want the equation for position. How do I find position? You could use S. I'm going to call it X. How do you find position given velocity?
The antiderivative of velocity.
Antiderivative of velocity. That means the antiderivative of root sine cosine. Integration skill time. How do you integrate that?
Use
U sub. What shall we let U equal?
Sine of X, or I mean sine of T.
Sine of T, and therefore du is? So that one worked out great, because that's, there's no monkey business, there's no, nothing, it's just straight up. So X is, when U integral becomes X is the integral of U to the 1/2 du. Okay? Now let's integrate. What is the antiderivative of U to the 1/2? 2/3 U to the 3/2. Remember, we raised the power by 1
Plus C.
plus C. Do we find the C first or sub back first?
Sub back.
So back, X is 2/3 of
Sine of
sine of T
T.
to the 3/2 plus C,
That is just
and
absolute.
then I'm done.
No.
How do I find the C?
Alright, so then, oh, T equals
Position is 3 when time is 0. Is sine of 0 0 or 1? It is 0, so C is
3.
3. Therefore, our complete equation is X equals
2/3.
All right. Done. Okay. Now you try both together in one problem.
And position.
I'm confused. I'm not sure what to do.
Plus C. Do we have to do this?
It's fine. You can add fractions. No problem.
Oh. In algebra.
It's not algebra, it's arithmetic.
Yes.
And arithmetic. Why, how calculated more? That's 18 times 3.
What? Why didn't you name
Because Colin. Thank you.
So check your velocity. Did you get something like t squared plus 3t minus 9? Good.
Whoa. Hold on.
That what? No.
Oh, wow.
Okay. How about your position? Is it complete? Did you get 1/3 t cubed plus 3/2 t squared minus 9t plus 10 thirds? Okay. Uh, it depends on your textbook. Some textbooks don't do this and some don't, but I was taught that you, in a course like this, when you're going to integrate twice and get two different c's, that you subscript those to indicate they're different, not the same c. So that's C1 and this is C2 over here. I wouldn't count off for something like that, but at least one professor I had did, so just want you to be familiar. All right, you with me? All right, how are we doing on time? We're good. Okay, so fundamental theorem, initial condition, a little blend of the rate problems we're dealing with movement. So, say I gave you acceleration function here. This cannot be integrated. I intentionally made it absolutely hideous, so you didn't try. No, it can't be integrated. I don't mean it can't be integrated by you. I mean it can't be integrated, period. There is
I'll take that challenge.
there is no anti-derivative. Okay? By anybody, by Gauss himself, or Newton himself, there is no anti-derivative to it. That said, how could you find v at 0, actually, given acceleration, oh, sorry, I gave you acceleration and an initial velocity. Use the fundamental theorem to express what that integral is equivalent to in velocity terms and give a sentence to explain the meaning of the integral. So what I'm saying here is that when you do the fundamental theorem of calculus, you anti-differentiate. It's the difference between the values of the antiderivative. What's the antiderivative of acceleration?
Velocity.
So this integral is equivalent to v at
5.
minus,
V at 0.
all right. Now then, that is easy to interpret it. It doesn't say actually find it, it just says express the meaning. Well, instead of looking at the integral expression, look at what it's equivalent to. That integral means you're finding the difference or change in velocity from,
0 to 5.
yeah, this is represents the change in velocity now, let's start to practice units, right? So when they ask you to interpret an integral, they actually look for 4 things. What it is with units, when it is with units. So represents change in velocity, units, what would the change in velocity be?
Meters per second.
In meters per second. Now when it is, from
T equals 0 seconds.
to,
T equals 5 seconds.
okay, what it is with units, when it is with units. How could you rearrange this expression to find the velocity at time 5,0? V of 5 is, so typically you write the
V of
integral
0.
second, so it's not unclear what's in the integral, what's not. So write v at 0 first. V at 0 plus the integral from
0 to 5.
of acceleration. Okay?
Yep.
Now that's the velocity of 5 is the starting velocity plus the change in velocity. It gives me the ending velocity. It all makes sense, eh?
Yeah.
Okay, so would you throw your expression into your calculator? That is no easy thing to throw in your calculator without errors, so be careful. And here we go. Your calculator doesn't actually take antiderivatives, it makes calculations. It's finding actual rectangle areas and adding them. Yes?
It's like if this problem didn't have the cardboard in the numbers for 5 seconds.
Oh, yeah.
First hand
Okay,
was
ready?
There's tangent of negative 1.
No, the first hand was change in negative.
good question was, if they don't give you units, should I just assume it's meters and seconds? The answer is, no, I'm an idiot. I thought I put in meters and seconds in the problem. So really, we shouldn't have had any units in there because they were idiots. Sorry.
11.42.
I heard an 11.42-ish.
10.423.
Ready?
Did you add the
I
11?
got 11.42.
Yeah, make sure you add the 1.
4 minus.
Oh.
Oh my, I plugged in after 0. Yeah, it actually cut in.
Yeah.
So can I get some confirmation? Are we getting 11?
Yeah, I can confirm.
Yes? 11.423.
423.
Yes.
How would they do problems like this before calculating?
You would do an approximation method. So there are, in Calc 2, you learn something like 23 different approximation methods. You'd probably use a Taylor series or something like that. So, they do approximations. They just wouldn't be as exact as your calculator is. Yes?
I got 412.
Oh, so we don't agree. 1 plus.
I am in degrees.
God, it had to be in degrees.
Oh, man, come on.
What are you in? What are you in?
Juniors, are you in degrees?
I'm in radians.
You're in radians, okay. 0 to 5, 0 to 5 of 70 to the sine of 4 minus 2. 0 to 5 of 7
Remember back in the day?
7p to the sine of 4 minus 2. Ay, ay, ay. Sine of 4 minus x. Sorry, I'm almost done. Arctangent of t over 12.
She did not explain it that.
Doo-doo-doo. Divided by 12 dx. I got 11.423
Yep,
degrees.
they were in degrees.
Oh, sorry, I think I got a mixture going on up there. If you borrowed one of mine, I've got a,
It was theirs. They were just not being very smart.
okay, good job, people. All right, let's go on to, do we have time for you yeah, try this one on your own, please. Yeah, we do. You have 3 minutes, go. Oh, did I skip something?
No.
Okay.
I did not see any units.
Yeah, leave units off, sorry, I would.
I guess 4.46. You get 4.64.
I didn't even get graphic on this.
Are we ready? Okay.
I got 4.46.
All right. Cole, I didn't ever call you. Cole, what is this meaning? What's the meaning of A? Say again? That's the derivative velocity. The antiderivative is change in position. The integral represents the change in position. There's a word for that in physics. What is it? Displacement. From when to when? Okay, always make sure you make reference to the time frame, not just what it is, but when it is. When you rearrange this, don't you need to add x naught over so it's positive and then subtract the integral back? So is it x4 plus or minus the integral? Minus. You're undoing the change that happened before. Okay, so, hi.
Hi.
Thank you. So when you do that, did you get something like 4.4608?
Four six.
All right, excellent. Sounds like we're doing well. Questions on set 54.
Wait, hold on. There it is. Q do 25.
And 60 and 1.
25. I like that you're not asking about 1. That means you killed it up to 16. I was hoping the optimizations were solid.
It's doable.
Okay. Here we go. 25. Okay, 25, x and y are two positive numbers such that x plus y is 20. Many of you lost points on this on the homework last week because you made a really huge assumption. Find the value of x and y so that xy is great as possible. Is it okay then to just say, oh, now I could do 20 and 0 and 1 and 19 and
Should be.
is that okay?
No,
What's that assuming?
But there was a number.
They're whole. Who says they're whole? You're going to try every number that's possible? Pack a lunch, baby. That's good. That's infinite. Okay, so that's a no. You've got to do calculus instead. So you're trying to maximize the product. I'm going to call it P, so I have an equation. Can I find where P prime goes positive to negative with 3 variables, or can I get it down to 2? Okay, what can I substitute?
X plus Y is 20.
All right, so if x is 20 minus y, or vice versa, then the product is y times 20 minus y, which is a...
Good morning, Demo Tower.
Oh.
Whoa!
Under God, indivisible, with liberty and justice for all. Wow. Okay, 16, yes? Everybody?
Summer high school baseball meeting this Wednesday, November 6th at 7 p.m. in the cafeteria. This also includes Devlin for ninth grade.
Boys that have big lockers for fall sports, please return your locker to Mr. Perigo as soon as possible. We need to get ready for winter sport athletes. Thank you. Please come by his office before school arrives.
This is Rocky. What'd you let you equal?
Has two competitions this week. Come out and support them this Thursday at Weaver High School at 7 p.m. and Saturday at 6 p.m. at the National Western Stock Show Complex, where they will compete to win a bid to nationals. They need your support when you inspire teams such as Valor and Columbine. So come show your support for the team that always supports you.
Senior high students, all students in grade 10 will participate in the Game of Life during 7th hour. Today, if your last name begins with D through G, you will meet in the Hampton office and Peter Smith will meet in room D100.
There will be a girls' soccer interest meeting in the cafeteria on Wednesday, November 6th at 2:45 p.m.
Students that are receiving an academic letter, please stop by the attendance window.
Attention Jack, would you like to have you and your friend's hilarious childhood photos for the yearbook? Send us your funny or cute childhood pics or recent or major throwbacks.
About one.
An opportunity to recreate this and relive your happier days.
Yep.
Send them to yearbook.jack@gmail.com or DM me your book Insta.
Musical auditions for Matilda are this Wednesday after school at 2:40 in the auditorium. If you have not picked up audition materials, please do so as Mr. White has before us.
What'd you call the rectangle? Base, height, length, width, X, Y, X, Y.
Happy nuts, love your red hair day. High five with Ginger in the hall.
Oh, yeah, Mr. Johnson. All right, right on. Look at that. You should get a skip 3 problems, am I right?
Yeah.
You can skip 1 problem on tonight's one.
Is there a notch between that and
I don't know.
How about a
Probably not. Probably. So, please read carefully what you're trying to minimize. I saw one problem, minimize area. That's not the question. It says minimize the fence, and that's perimeter. So be clear in your reading. The perimeter is 2x and 2y. Now we want to get down the number of variables. Use the fact that the area is 3,600 to substitute. And then your life will be much easier because it's only 1 variable instead of 2. Make your life easier in terms of taking a derivative. Now find where P prime goes negative to positive. Some of the people are still having trouble with the algebra, which is understandable. The algebra is not super easy. I would suggest that you use this basic idea. Adding and subtracting doesn't have fast rules of positive or negative. When I say, hey, what's a positive plus a negative, you'd say, depends on which is bigger. But adding, multiplying and dividing, it has fast rules for what's bigger, what's positive, what's negative. So always strive to make a product or a quotient. In this case, I would make a quotient by getting a common denominator. Then you will be on your way. The bottom zero's kind of bogus. This should be 2x squared, yeah. The bottom zero is kind of bogus because x can't be 0, so the top 0 is x equals 60, which means y equals 60, and therefore the fence, which they also asked about, is 60 by 60 by 60 by 60, or 240. The units are all meters, and you are done. All right. We'll go over the test tomorrow. If you have not taken the test, make sure you take it by the end of the day, or else we'll count it done. Have a good day. They are not in. The multiple choice is done, but the free response is still in tomorrow.
skip the free response?
We'll see how it goes. We gotta learn. How else are we gonna learn?